Welcome to our machine learning series. Today, we will understand a very popular supervised learning algorithm known as logistic regression. Make sure you check out the previous videos to know the fundamentals of machine learning and supervised learning. Let's get started. Logistic regression is a supervised learning algorithm that allows us to predict categorical outcomes based on a set of independent variables. It is widely used in various fields such as healthcare, finance, marketing, and more for classification tasks. Logistic regression helps us answer questions like, will a customer buy a product or not? Will a patient develop a certain disease or not? These are yes or no type of questions for which logistic regression is a perfect fit. Now let's understand how logistic regression is different from linear regression. In linear regression, we predict a numeric value based on the independent variables. We fit a straight line in the data points. In the figure, you can see that linear regression is predicting the score of students based on the number of hours they study. Here, the target variable is continuous in nature. On the right side is an example of logistic regression, where we are categorizing whether a student will pass or fail based on the number of hours they study. Notice that the target variable is categorical and is predicting the pass or fail status of a student. So linear regression has a continuous dependent variable, whereas logistic regression has a categorical dependent variable. How does logistic regression work? Logistic regression works on probability. The probability of occurrence of an event is calculated using logistic function. The logistic function is the heart of logistic regression. In binary logistic regression, which deals with two possible outcomes, usually labeled as 0 and 1, the equation takes the form P of y equals 1 given x equals 1 divided by 1 plus exponential function raised to the power of negative z. This function is called a logistic or sigmoid function. Here, e is the base of the natural logarithm and p of y equals 1 given x represents the probability of the occurrence of event with category 1 given the input variable x. And z is the linear combination of the input variables weighted by coefficients. This is the logistic or sigmoid function. The sigmoid function has an S-shaped curve that allows us to squeeze any real valued number into the range 0 to 1. So we reduce the value of z to a probability using logistic function. After calculating the probability, we compare the probability with the threshold value. Usually, if the value is greater than the threshold, the prediction will be categorized with label 1, else with label 0. Simply saying, if the conditional probability of y equals to 1 given x is greater than or equal to the threshold, the event with category 1 will be predicted. Else, the event label 0 will be predicted by the model. Let's understand the working of logistic regression with an example. Suppose you have this data where we are predicting whether a student is admitted to a university or rejected based on the test score. Here, score is the independent variable which is continuous in nature, and category, admit or reject, is the categorical dependent variable. First, we need to convert the outcome variable admit or reject into numeric values. Let's assign 1 to represent admit and 0 to represent reject. On the left side, you can see the new dataset with numerical values assigned to the categories. And then on the right side, we have plotted this data. See that on the graph, the x-axis has the score of students and on the y-axis, we have the corresponding category, which is either 0 or 1. Now first, we need to calculate the coefficients b0 and b1 for our equation, as there is only one independent variable. To estimate the coefficients, a technique called maximum likelihood estimation is used. In this technique, the coefficients are iteratively updated based on the observed data until convergence is achieved. Convergence occurs when the model has reached a point where further updates to the coefficients would not significantly improve the model's performance. After the coefficients are plugged into our logistic function, we will get the curve for our logistic regression model. This logistic regression model finds the best curve that maximizes the likelihood of the observed data points. We also set the threshold to which the probabilities will be compared. Let's assume that the threshold for our example is 0.5. If the probability for a particular score is greater than 0.5, then the predicted category will be 1, else 0. Now let's say we want to predict whether a student with a score of 50 will be accepted or rejected. See, where the value 50 on the x-axis meets the regression curve, and then check the y value for the same. The probability is 0.62 for a score of 50. This probability is greater than our threshold, which was 0.5. Hence, the model will predict category 1, which means, according to logistic regression, the student will be admitted. Types of logistic regression. First, binary logistic regression is the most common type of logistic regression and is used when the outcome variable has two categories, such as yes or no, pass or fail, or 0 or 1. And in our previous example, we used binary logistic regression with categories admit or reject. Multinomial logistic regression is used when the outcome variable has more than two unordered categories. For example, predicting the type of flower from rose, daisy, and sunflower based on their characteristics. In ordinal logistic regression, we have a specific order or rank of our categories, but the intervals between them may not be equal. For example, predicting the severity of a disease, mild, moderate, or severe, based on various factors. These are just a few examples of the types of logistic regression, commonly used in various fields. In this video, we covered what logistic regression is and how it is different from linear regression. We also learned about the working of logistic regression and its different types. We will cover more supervised and unsupervised learning algorithms in future videos. So stay tuned and thank you for watching.